Hello everyone, today we're going to be going over Pythagorean triples. In this particular problem we're supposed to find Pythagorean triples of the form 16, y, and z. So in this one they don't have to be primitive themselves. They don't have to be Pythagorean they don't have to be primitive Pythagorean triples either. So just any of this kind of form. So with this being said, we're looking at right triangles and finding particular kinds of x, y, and z that work. So going into this, we have looking for integer solutions to 16 squared plus y squared equals z squared, or our hypotenuse. Over here we can use the identity z squared minus y squared equals x squared. And when we use this identity, we can get something we can remember from algebra: z plus y, z minus y equals x squared. So that means we can rearrange this right here into z minus y, z plus y equals 16 squared, and then 16 squared is 256. Now we have to factor 256. 256, as we know, this is a computer term. So a computer term, we don't even have to think about the math. It's 2 to something power to the 8th power equals 256. So the factor pairs, we have a few that come from this Now of this though, we can also look at knowing that 2 to the 8 is also a perfect square. 2 to the 4 squared. So that means that there's 3, or sorry, not 3, there's an odd number of factor pairs. And as I accidentally just said, in the end we're going to have 3. So first things first, we can't, one of the factor pairs obviously is 1 and 256. We can't use that. That's the trivial situation. Alright, so then what we have next? Well, then we have 2, 4, 8, and 16. So 2, 4, 8, and 16. So when we have those, we can pair them up like so. And we have 2, 128, oops. 4, 64. 8, 32. And 16 times 16. Okay, they also have to be whole numbers and not themselves, so that means we get rid of those possibilities. What I mean by that is that we do need to use z minus y equals a, z plus y equals b, so that way we can get a plus b over 2 equals z, and y equals b minus a over 2. So then we need to pick pairs a and b such that both z and y are integers. So that's what I mean by that. So with the first triple, we have z is 2 plus 128 over 2, which is 65, and then y is 128 minus 2 over 2, which is 63. This leads to the triple 16, 63, 65. And then if we check that, we get 16 squared plus 63 squared equals 256 plus 39, 69, which is 65 squared. Okay, let's go through our second triple. Our second triple is 464. Okay. So then we do again the same process, plus and minus. Pick a number first. 2. Okay. And then this equals 30 and 34. Sorry, getting messy here. So then this one is 16, 30, 34. Okay, let's go down to a cleaner spot here at the bottom. Oh, let me also highlight these. Come back to that later. And then for the last one, same thing. So we have z equals y equals over 2 over 2, and then a plus b. So that was 4 and 64, and then 64 minus 4. Okay. And that equals 34 and 30. Oops, I wrote my notes wrong. My way said that doesn't make any sense. This is 65. And then 64 minus 4 is 15. No? Hold up. Basically, I'm not actually... I wrote my notes completely wrong, reading them wrong. Yeah, okay, so hold up. 34. 30. Okay. And then this one was supposed to be... Okay, I got this backwards. This one was 2... So 128 plus 2, 128, 128 minus 2 over 2 over 2. Okay. So 130 is 65, and then 126, 63. Okay, and then for this Pythagorean triple we have 16, 63, 65. Double check I didn't make any others. Oh wait, I did that one already. Okay, I'm just tying myself in knots here. My bad. 8. Plus 32. 8 minus 32 over 2. Okay, here we go. And then that's 40, 20, 32 minus 8, 24, 12. And so this one is 16, 12, 20. 1, 2. Yeah, 1, 2, 3. Okay. And so those are 3 Pythagorean triples right there. So these are not, of course, not primitive. Okay, so yeah, as long as you don't just keep doing the same ones over and over again and read your notes right, you should be fine. Anyway, so that's how you find them.